Have a look at this paragraph based problem from JEE Advanced 2017. So the problem says P and Q are integers and alpha and beta are the roots of this equation x square minus x minus 1 equal to 0. So it's very much clear that they are conjugate surds. Okay, and further it is given that we are defined an as p alpha power n plus q beta power n, and we need to find out what is the value of a12. So some kind of a fact is also given in this question, which says that if a and b are rational numbers and if a plus b root 5 is 0, then it implies a is equal to b equal to 0. Okay, so now let's proceed and try to solve this problem. So here we need not have to find the value of a12, but rather simply write it down as some kind of a formula involving the previous terms. So that is a straightforward thing, because we very well know if we can write it for a n plus 1. So if you take a n plus 1, it is equal to p alpha power n plus 1 plus q beta power n plus 1, right? And similarly, if we take a n, that will be equal to p alpha power n plus q beta power n. And finally, a n minus 1 will be p alpha power n minus 1 and plus q beta power n minus 1. So what happens if we so have a look at this expression, it is x square minus x minus 1. Okay, so if we take a n minus or rather a n plus 1 minus a n minus 1, let's see what happens. We can always take p alpha power n minus 1 common, right? P alpha power n minus 1 may be taken as common in these three terms, and then it becomes alpha square minus alpha minus 1. Okay, and similarly, if we take q beta power, so q beta times n minus 1, if we take it as common, then what is remaining? The remaining terms will be beta square minus beta minus 1. Now what is this? The alpha and beta both are roots of this equation, and therefore this is equal to 0 and this is also equal to 0. So which means this kind of a recurrence relation is true. That is, a n plus 1 minus a n minus a n minus 1 is always equal to 0, or in other words we can write a n plus 1 is equal to a n plus a n minus 1. Okay, so on putting the value of n is equal to 11, what do we obtain? We get a12 is equal to, so we have put the value of n is equal to 11. Okay, so it means a11 plus a10. Okay, so it's a simple problem. You would have definitely done similar kind of problems in quadratic equations, wherein you find a recurrence relationship just based on the roots of the quadratic equation.